This video is going to demonstrate how to create the bolt for the bolt and the nut for CAD quiz number 3. Now, if we look at the bolt here, we have some dimensions we need to be aware of. We have a 14 millimeter diameter, which when we're talking about threads is known as the major diameter because it's from the outsidemost point of the thread to the opposite outsidemost point, and that's calculated in a diameter. And that's actually where we're going to start with this. We're going to use the 14 millimeter diameter in our calculation to create a spiral helix, or essentially the line that we're going to sweep around to make this cut. Also important for that information is this 40 millimeter height. The head we're actually going to extrude as a secondary step. So let's go ahead and get started here. I'm actually going to start this with a 3D sketch. So if you click, not the 2D sketch, but if you click on that bottom bar and click 3D sketch, you're going to see helical curve pop up, and that's where we're going to start with this. Now, the information from this drawing is actually what we're going to put in here, but we need to choose the right set of information. So we need to align the drop box with what we have. And if we think about it, what do we have? Well, I've got diameter, I've got height, I've got pitch. The pitch is the distance from one thread to another, and I know that is 2 millimeters because it says so right here. So I'm going to go with pitch and height. So my diameter, here we go. So actually, first thing, take a step back and look at dimensions. This is millimeters. I need to change my document quickly to millimeters. Now I can proceed with my sketch. Okay. Where to go? Oh, here's my 3D sketch tab. Helical curve. I'm going to do pitch and height. My diameter is 14 millimeters. My height is 40. My pitch is 2. And I have no taper. So this is actually correct. Now we are going to need to fully constrain this. So I'm going to start by putting this right on my origin. And I want to orient it up. So I'm going to use this axis here. And now it's going to spin around, so I will need to constrain that aspect of it. But for now, I can just click it. Okay, so there's my spiral helix. Now, to fully constrain this guy, you have to make sure that this point is on the origin. This axis is using one of the origin axes, which I believe this is. And lastly, you need to take one of these two endpoints and coincident it on one of the planes. So that's what we're going to do right now, because that's what's missing. So figure out which plane you want, which there's pretty much only two that are going to work. I'm going to do the XY plane actually. So I'm going to take coincident, select my endpoint, and select my plane. And it should have locked that in now. And I should no longer be able to rotate it. But I can see that despite my effort to try and use the origin, that didn't work. But I can easily go back and do that. I'm going to select the starting point of my center line, and then I'm going to click center point. I'm going to do a collinear because I want to take this line and put it on one of my axes, which I think was the y-axis. So there we go. Fully constrained now, ready to rock. Finish that sketch. Now for my next sketch, I actually want to make the solid that we're going to cut out using this path. So I'm going to do a 2D sketch. I'm essentially going to start at the bottom of this guy. And I'm just going to create a 14 millimeter circle using the origin. And that should be all I need. I'm going to extrude this 40 millimeters because we know that's how far it's going. And there is my solid. Now, I suppose you could do the solid first. I just find it easier to do the spiral helix with nothing else in the way. Now, for any sweep, I have my path and a profile. So I need to create my profile. So what I need to do is take the same plane that I used to coincident to keep the spiral helix from rotating, and I need to draw on it. And that is this guy. I like using slice graphics to kind of cut it at the plane so I can draw right on it. And now what I'm going to draw is this right here, this 2 millimeters. So it's kind of going to look like a triangle, but it's going to be rounded at all sides. This is what I'm going to create. I'm going to do it actually right above the piece so I can sweep all the way through it. Okay, so let's think about what this is going to look like. So I'm going to be using lines and arcs. I'm going to have kind of this V shape going on, but I'm also going to have some arcs as well. I can use a fillet here. Oh, if that lets me. Actually, I'm going to stay away from fillet. I'm going to make this as easy as possible. Now, first things first, make sure you have tangents between your lines and your arcs all the way around. I'm going to put in some construction lines to constrain everything. And if this did not create a collinear relationship with the existing edge, then you need to do that, but I think mine did already. Make sure your endpoints are on the line. Looks good there. Now let's get our dimensions in there. So I know from the tip of this to the tip of this is 2 millimeters. I know that my angle here is 60 millimeters, because it's always 60 millimeters for single point threads, or standard single point threads, I should say. And I know that these need to be equal so that we have symmetry here. I know these need to be 0.3. It says so on the diagram. I could make those equal to each other. I know if I want a complete half arc, that the center point and the end point should be horizontal on both sides. And I think I'm missing the dimension here, but that's going to be the same 0.3. Let's see where we're at. What are we missing? Oh, okay. I have to put this endpoint here. So I'm going to start this cut right at the edge of that. And that is all the dimensions I need. And that's everything I'm given. There's an attachment that talks about threads. It looks complicated, but essentially that's where the 60 degrees come from if you want to see it for yourself. But at this point, I actually just need to make sure that I enclose this by making that non-construction. But now I have an enclosed profile with the correct dimensions, and I am ready to do my cut if everything cooperates, right? So let's go ahead and sweep. It picked out my profile. Now I need to select my edge. Make sure I'm cutting, and the preview looks okay. Let's see what happens. All right, that actually looks really good. I have the rounded profile because I put those arcs and radii dimensions in. All I have to do now is come down here and create the hex head. So I'm going to sketch right on this. I'm going to do a polygon, and a hex would be 6, which is usually the default. I'm not going to dimension this quite yet. So let's see here. So the depth is going to be 8 millimeters. That's going to be my extrusion depth. And my flat to flat is going to be 20 millimeters. Make sure we fully constrain this. And we can extrude to 8 millimeters. All right, that looks good, seamless. Now in here, you're just going to put some initials in your period. As you can see over here, you guys should know how to do that at this point. Just do some text and extrude it. Then one thing that is good to do, and I'm going to ask everybody to try, is to put a chamfer on this. Now, because of the spiral helix, we can't put an actual chamfer tool. It would have a hard time selecting what we want. So what we're going to do is cut this guy in half and just do a simple revolve cut, because in real life, that's what it would most be similar to. So I'm going to take one of those planes that's going to cut this guy in half, probably use the same one I used before. I'm going to sketch on that. Right click and slice so you can get to your plane. And you have a little bit of freedom here to figure out how best to chamfer, but usually a chamfer is just a triangle. I'm going to use the geometry here of this edge, and I will probably go to this point if it'll take it. Sometimes with the spiral helix, it's not too cooperative, but essentially I'm just creating a triangle. Make sure you cut enough. But like I said, this part is not quite as important. As long as you get something close to this that's cutting all the way through, should be all right. But we do always want a dimension. I'm going to do a 1.5, so not quite one entire pitch, essentially, thread to thread. And I'm just going to use my equals to make a nice right angle triangle, if I can. Never mind, I'm going to go this way. 1.5. That should be all I need. Now let's make sure my axis is visible. So let's see, that's the axis I want. I'm going to make that visible so I can use it. Oops. That was my Y. I'm just going to make that visible for the time being. Let's do our revolve tool. Select our profile. Select our axis. Make sure it knows it's cutting. And let's see what happens. All right. Oh, that did pretty well. It kind of left this weird flat spot, so I'm probably going to go back and change that slightly. But it essentially did what I wanted. I just have to change the look of it slightly. Okay, so this guy, sometimes it's actually beneficial to make it a little larger than you think it needs to be. And in the real world, that probably does approximate a real chamfering process. All right, let's see here. Probably could have done this simpler, but it's okay. It's how we learn sometimes. I'm just going to make these two on both sides and see what happens. All right. Let's see what happens with the revolution now. Let's see, did that update? So what portion am I still leaving here? There's kind of a weird spot still sticking up. All right. So it's really close, but I'm going to add on a little extra because I'm not getting exactly the effect I want. I think this is not on the very top like I thought it was. No big deal. Just add something to the top. Just going to add a 1/2 mil here. 1/2 mil here. And it's kind of quick and dirty because I just want to get it done. Don't want to make this video too long. Go back in here, select this portion too. Now let's see what happens. Still being a little goofy, but you guys get the idea on how you can do that. I just need to modify this a little bit. This part looks really good. I just have to modify it to get rid of that part sticking out of the top. And I'm going to go ahead and do that, but I want to stop the video now because I think you guys understand enough to go ahead and do this bolt. Now, one quick note, the reason that we do these rounded edges and we don't just have straight corners, is those corners are where this thing will break, especially when we 3D print it in our class. I want this to be stronger rather than weaker and break easily. So we put in these, these radius and round everything off, because you will be printing it and testing it and putting a nut on there, and I don't want it to break on you. All right, guys, go ahead and make it happen. I'm sure you can do this now.